The sun is the primary source of energy for the earth. It is the vital source of energy because of which life is possible on the earth's surface. The sun's rays, which come out of the photosphere of the sun, is radiated in all directions on the space as short waves which are received by the earth, which is a source of heat energy for the earth's surface. 2 billionth or 2 units of energy out of a billion units of energy radiated by the sun reaches the earth's surface, so which is very important for biological and physical surface phenomena which happen on the earth's surface. So rays which comes out of the sun towards the earth is called as solar insolation. The reason the Earth receives only a small part of the solar insolation is because of the small size of the Earth in relation to the entire universe, and also the distance of the Earth from the Sun. Factors affecting insolation. So, the amount of insolation received on the surface is not uniform, it varies from one place to another. So, the equatorial region, which is near the equator, and the tropical region receives more solar insolation and is hotter in comparison to the temperate zone and the frigid zone. There are various reasons for this. The first factor is angle of incidence. Since the earth is spherical in shape, the sun's rays do not fall on every place equally, but it strikes the surface at different angles and at different places. The angle formed by the sun's rays with the tangent of the earth's circle at a point is called as angle of incidence. So when the sun's rays is almost overhead or the rays are falling vertically, that means the angle of incidence is larger. They are concentrated in a small area, so the effect of the insolation is more and the amount of insolation is more. So this happens near the equator and around the tropics. So when we come towards the equator, the angle of incidence is more. We receive direct rays of the sun or the vertical rays of the sun, and thus we cannot see our own shadow at this point. If the sun's rays are oblique or slanting, the angle of incidence is small. That is, the sun's rays have to heat up a larger area, so longer path is taken by the sun's rays. So when we travel from the equatorial region towards the temperate zone and the frigid zone above 66.5 degrees north and south of the equator, the sun's rays begins to become slanting or oblique. So it spreads over a larger area. The impact of the heat energy becomes less. The duration of the day. Duration of day also varies from one place to another and season to season. Longer the duration, greater is the amount of insolation which happens near the equatorial region or the tropical region. And conversely, shorter the duration of day leads to less insolation. Latitudes near the equator receives vertical or direct rays of the sun, so the amount of solar insolation is more, as a result of which the duration of daylight is also equally large. And therefore, this heat energy and the solar radiation enables thick and luxuriant growth of forests in the equatorial and the tropical regions. So, as we are traveling from the tropical region to the temperate region, the temperatures become cooler as the sun's rays become more and more slanting. And when we reach the frigid zone or the polar regions, it becomes extremely cold. And there is also a layer of permafrost as the temperatures become cold due to the slanting rays of the sun. Transparency of atmosphere. That also determines the amount of insolation reaching the Earth's surface. Transparency means cloudliness or cloud cover, thickness of dust particles, water vapor as they reflect, absorb, or transmit the insolation of the sun. Thick clouds hinder insolation rather than clear skies, and water vapor also absorbs a large amount of insolation. So, regions which have cloud cover or a lot of cloudliness receives less amounts of insolation, and therefore precipitation also absorbs huge amounts of heat energy. Heat budget. Insolation is the energy transmitted from the sun as rays in the form of short waves and scattered in the atmosphere.
and also reaches the Earth's surface. Whereas the Earth also absorbs the solar radiation and radiates it or reflects it back as any other object would do, and this is called as terrestrial radiation, and it is in the form of long waves. Heat budget means balance between the solar insolation and the terrestrial radiation. Suppose the total heat energy received is 100 units. Now, roughly 35 of it is reflected back to the space before reaching the Earth's surface. Out of these 35 units, 6 units are reflected from the topmost layer of the atmosphere. 27 units are reflected by the clouds, and 2 units by the snow and ice and other forms of precipitation. So, out of the remaining 65 units, only 51% or 51 units reach the Earth's surface, and the rest 14 units are absorbed by the gases, dust particles, and water vapor in the atmosphere. So, terrestrial radiation is when the heat energy is absorbed by the Earth's surface, and this energy is radiated back at night in the form of long waves into the space. So, 34 units out of the 51 units that the Earth radiates back is absorbed by the atmosphere. 17 units go back to the space, that is incoming and outgoing radiations, thus maintain the balance of the heat on the surface of the Earth, as the total amount of solar insolation which is coming from the sun is not completely absorbed by the Earth's surface. It is getting lost in between the layers of the atmosphere and the clouds and the dust cover. That is why the Earth does not get too much heated up during the daytime. And at night time, whatever energy that was absorbed by the Earth's surface gets radiated back into the space, is again absorbed by the layers of the atmosphere, gets scattered, and also does not allow the complete loss of energy into the space. So, this balance of heat energy on the Earth's surface enables life to exist on the Earth.